Hello all, I'm Dr. Vishnu. Now I'm going to discuss one of the interesting topic, green chemistry. Green chemistry, it is similar to sustainable chemistry or circular chemistry. It is an area of chemistry and chemical engineering focused on the design of products and processes that minimize or eliminate the use and generation of hazardous substances. So we can define this green chemistry as the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. Actually, this green chemistry is emerged from a variety of existing ideas and research efforts such as atom economy and catalysis in the period leading to the 1990s in the context of increasing attention to problems of chemical pollution and resource depletion. This green chemistry discusses the engineering concept of pollution prevention and zero waste both at the laboratory and industrial scales. It encourages the use of economical and eco-compatible techniques that not only improve the yield but also bring down the cost of disposal of waste at the end of a chemical process. So, this green chemistry focuses on minimizing waste, using renewable resources, and designing chemicals with minimal hazard. In the year 1998, Paul Anastas and John C. Warner published a set of principles to guide the practice of green chemistry. There are 12 principles which address a range of ways to lower the environmental and health impacts of chemical production and also indicate research priorities for the development of green chemistry technologies. So there are 12 principles listed here: prevention of waste, atom economy, less hazardous chemical synthesis, designing safer chemicals, safer solvents and auxiliaries, design for energy efficiency, use of renewable feedstocks, reduce derivatives, catalysis, design for degradation, real-time analysis for pollution prevention, and inherently safer chemistry for accident prevention. So these are the a set of 12 principles which emphasize on minimizing the waste or minimizing the pollution, reducing the cost, prevention of the accidents in the pharmaceutical industries or chemical industries, and using the renewable sources rather than the petrochemical sources, which are covered by the 12 principles of the green chemistry. So let us discuss one by one. Prevention of waste. So it is better to prevent waste than to treat or clean up waste after it is formed. So let us take one example. In a manufacturing process, in addition to the byproducts, the unreacted starting materials, that means reactant, also form a part of waste. So this waste along with the byproducts may be disposed in the atmosphere, sea or land, which adds to the pollution. That is the reason in the process every step must be planned to minimize the waste. The second principle, the important one, is atom economy. Atom economy, it can be defined as the maximum incorporation of the atoms of the reactants and reagents into the final products is called atom economy. So that you can calculate using this formula. Atom economy is equal to the molecular mass of the desired products by molecular mass of all the reactants into 100. So this is one example. You can see Claisen rearrangement and Wittig reaction. So Claisen rearrangement, it is a 100% atom economy reaction. You can see the molecular mass of the reactants 112 grams per mole, and the products molecular mass also same 112 grams per mole. So there is a 100% incorporation of the starting materials or atoms into the products. When it comes to the Wittig reaction, so here 58 grams per mole, 290 grams per mole, these are the two reactants which are involved in the reaction, but the yield is just 70 grams per mole. So there is a wastage or byproduct formed in this reaction, it is not 100% atom economy, just the yield is just 20% of the reactant molecules. Atom economy quantifies the efficiency of a chemical reaction in incorporating reactant atoms into the desired product, thereby minimizing waste. A higher atom economy indicates a more sustainable and environmentally friendly reaction, as it reflects a greater proportion of reactant atoms becoming part of the final product. The third principle, less hazardous chemical synthesis. In a process, it is important to prevent or minimize the formation of hazardous products which may be toxic or environmentally harmful. Here we can see one example, Bhopal gas tragedy. It is a there is one pesticide company which is synthesizing this methylamine. So one of the intermediate product is methyl isocyanate. So in the year 1984 this incident happened. This gas was leaked in the late night, which caused many casualties. So when according to statistics, almost 5 lakh people in the vicinity of this pesticide company were exposed to the highly toxic gas methyl isocyanate. So it is considered to be a world's most industrial disaster. Actually, this if we avoid the formation of this methyl isocyanate process, so we can prevent the uh, accidents, or we can follow a less hazardous chemical synthesis process. The same conversation, for the same conversation, we can avoid this route where methyl isocyanate is formed. So alternative process may be used to synthesize this methyl amine. So design chemical reactions and synthetic routes to be as safe as possible. Consider the hazards of all substances handled during the reaction, including waste or byproducts, etc. Next, the fourth principle of the green chemistry, designing safer chemicals. Designing safer chemicals, so it deals with the chemicals or pharmaceuticals synthesized should be safe to use. Usually, pharmaceutical industries they develop drugs, they design the drugs to help ill effects. So here we can see one example, thalidomide. It is a drug prescribed for nausea and vomiting during pregnancy, which had given adverse effects, led to birth defects like deformed limbs. So later this thalidomide was banned and withdrawn from the market. So the any drug discovery process minimize toxicity by molecular design, predict and evaluate aspects such as physical properties, toxicity, and environmental fate throughout the design process. After that, it can be considered for the drug. Next, fifth one, safer solvents and auxiliaries. Usually, some solvents like benzene is there, carbon tetrachloride, many organic solvents, they are all carcinogenic agents. So, by avoiding such carcinogenic solvents, use some green solvents like water or ethanol, supercritical carbon dioxide, etc. Such alternatives may be used for reducing the harmful effects of the solvents, and also utilizing renewable feedstocks for the auxiliary substances also minimize the health hazards. So that is the reason, choose the safest solvent available for any given step in the process. Minimize the total amount of solvents and auxiliary substances used, as these make up a large percentage of the total waste created. Next principle, design for energy efficiency. You can see generally the conventional heating methods. So conventional heating methods not much energy efficient. It requires a lot of heating process and time, and yield also very low. The rate of these reactions are very slow. Conventional heating methods are not energy efficient, and the rate of reaction may be slow. So that is the reason, use some alternative energy sources like microwave assisted synthesis, ultrasound assisted synthesis, or you may be use the sunlight or UV. So you can see these are the two instruments. So sonicator, which is used for the ultrasound synthesis process, and also microwave oven, in which microwave assisted synthesis can be performed. So these are highly efficient, which can save the time, and some reactions which cannot occur or which are very slow by conventional method can be achieved through this energy efficient techniques like sonicator and microwave processes. So that is the reason. Choose the least energy intensive chemical route, avoid heating, cooling, as well as pressurized and vacuum conditions. Mhm. The next principle is use of renewable feedstocks. So, in a chemical process, raw materials should be mostly renewable sources. So maybe they are obtained from the sugar cane, algae, wood, or corn, short rotation herbaceous species, or wood waste, biogas, etc. They can be used as a raw material feedstocks. So here use chemicals which are made from renewable sources rather than equivalent chemicals originating from petrochemical sources. So you can see many antibiotics, many natural products. They are all obtained from the renewable sources. Reduce derivatives. So unnecessary derivatization like blocking groups, protection or deprotection, temporary modification of physical or chemical method should be minimized. At the outset, minimize the use of temporary derivatives such as protecting groups. Avoid derivatives to reduce reaction steps, resources required, and waste created. The next principle, catalysis. This is one of the important principle in the green chemistry. So generally we know stoichiometric reagents. You can see this is one example here, the reduction. So reduction of this keto group using sodium borohydride. So this is a one of the stoichiometric reagent, so which is also forming some byproducts. These byproducts are added to the waste. Instead, using catalytic reagents, that means catalyst in minute quantities or small quantities, it involves in the reaction which may be recovered after completion. So using this palladium graphite, palladium carbon catalyst. So this process can be done. The reduction of the keto group be done very efficiently without producing any chemical waste. So not only this palladium catalyst, so there are many examples like zeolite catalyst or phase transfer catalyst, which are very efficient in the organic synthesis process. Apart from the biocatalysts, so which are produced from the yeast or enzymes, so they may be used in the synthesis process. So finally, choose catalyst to help increase selectivity, minimize waste, and reduce reaction time and energy demands. So one can see these enzymes, biocatalyst, they have more selectivity compared to this other phase transfer catalyst or any other metal catalyst. Design for degradation. So these chemical products should be designed so that at the end of their function, they do not persist in the environment and break down into the small products. Otherwise, they will be added to the pollution. So they must be degraded not only in the environment, even if a medicine or a drug, it is administered into the body. So after its end use, it must be excreted. That means it must be degraded or decomposed into small products and be excreted from the body. So otherwise it will become a toxic material which adds to, which is health hazardous. The next principle, real time analysis for pollution prevention. So during the chemical process, there is a possibility of release of toxic gases, harmful vapors, and also some byproducts which formed are very dangerous, health hazardous. So, in a process, always monitor chemical reactions in real time. as they occur to prevent formation and release of any potentially hazardous and polluting substances. So always the analytical methodologies. So analytical methodologies need to be developed to control the formation of hazardous substance. So if any toxic gas is released, it should be identified within no time so that we can minimize the pollution or health hazardous. The last principle of the green chemistry, inherently safer chemistry for accident prevention. So in recent days, we can see many accidents in the pharmaceutical industries or this API, active product ingredient industries. So here, the substance and the form of chemical used in a process should be chosen so as to minimize chemical accidents, explosions, and fire accidents. So you can see these are some pictures taken from the web, pharmaceutical industry accident pictures. That is the reason. So a chemical process must be monitored or always developed in such a way to prevent the accidents. Not only the process, but also we should think about the chemicals which are used in this process. So choose and develop chemical procedures that are safer and inherently minimize the risk of accidents. Know the possible risks and assess the beforehand. So before the accident occurs, so handle the situation carefully and thereby prevent the accident. These are the total 12 principles of green chemistry. So with this I conclude the topic. Thank you.